Segment 1. Now, let's analyze the dimension modification and position of the transfer. We draw a board. And in this mode, let's first look at the current dimensions. On the right is the original size. The new dimension shows the width is 18, length is 600, and height is 2000. If modified, it changes to 1000, and if the length is 300, it corresponds to 300. There's a position here, currently at 00. How to draw the second board and compare them? Let's copy it. The board on the right is made using the Chinese version, so its properties are the same. But what's the difference? We can click to see. The dimensions might be the same, but mainly look at this position, it's 00. Segment 2. For the second board, it's 50. How did this 50 come about? You can see this board, its C is 0. We know Z controls the height, whether it's up or down. If it's 0, they're on the same plane. If a board below is placed, they're on the same plane. Its Y is 0. We know Y is front and back, so the two boards are aligned at the back. The only direction change is XX. This is the board's edge. This corner is a 0 point. If it's 0, this board is 50, meaning the distance from this board's edge to this point is 50. You can measure the space between the two boards, which is 3232, plus the board's own edge number, which is 50. So, this X. Segment 3. Its coordinate is 3, a 50 position, all. Give it 100. So, the distance from this board's edge to the corner is 100. We can adjust the indicator to give it 500. It might not be visible, so I rotate the board. The back corner of this board is 500 from the 0 point forward. Similarly, if you give it 500, it raises 500 in height. If you don't want to raise it, it's a negative 500, lowering it by 500. So, this X corresponds like this. For example, we directly draw a board, not using other methods. We stick this board and then randomly place another board next to it. This layer board, I want to move it below this board without aligning, just using certain coordinates. Segment 4. Move it below, so this board needs to be brought to this board above. This layer board needs to be brought to this board above. First, their coordinates must be aligned. If aligned, their X coordinates must be the same. So, this board's X is 0, so this board's X is also 0. After 0, let's look at the board's height, which is 1000. If the layer board below is raised by 1000, it will reach the top edge of this board. So, if you raise this board by 1000, it directly goes up. If the board was initially placed differently, like rolling forward, raising the board makes them seem aligned. But if we slightly rotate, we'll find they aren't actually aligned. Segment 5. The relationship is that if they are aligned at the back, their coordinates must be the same. Whether moving forward 500 or moving the board back 500, they must have a corresponding relationship. If you want them aligned at the back, their coordinates must be the same. For example, if the sideboard is moved forward by 100, the top board must also move forward by 100 to align. If you move 90, it won't work, they aren't aligned. If you raise it by 1000 instead of 1000, there will be a gap. So, the board's height is always the board's. Segment 6. The lowest point is a 0 point. So, the bottom edge of this board is raised by 1000 to cover the board. This is a dimension modification, selecting a board and choosing this board. On the right, there's a dimension option too. Modify. Below is its position information, where the board is located for. Modification. This creates a corresponding relationship, dimension by dimension. Here it's organized, dimension and position.